Hello, my name is Jim Slada. I'm from the University of Toronto. I'm a researcher in the learning sciences, and I study a form of learning called collective inquiry. This fits within the learning communities approach. I like to call it knowledge communities, but I think they're relatively the same thing. I have been doing my work with a group of students and technology designers and teachers here. We call ourselves the Encore Lab. You might find our website. We work and have done a variety of projects in K to 12, focusing on upper elementary, which is grades 4 and 5 and 6, and secondary in science topics. So our work is driven by a theoretical model called knowledge, community, and inquiry. The goal of this model is essentially to inform the design of curriculum that is substantive. So these would be multi-week or even multi-month long curriculum units that target a very specific set of learning goals. So this would be, for example, high school chemistry or biology, an entire course scope. How do I design a course like that such that it leverages the individual contributions in an inquiry format, but also in a collective epistemology or in a collective sense where we are all feeling that we're in the learning process together and we need one another to make progress. So the goals of that kind of learning are clear, and they've been identified by others, including Anne Brown, Marlene Scardamelia, but enacting that in a secondary level has been quite elusive, in part because of the need to cover the depth that these science courses have. We've been working together for years now to create this model. The model has a set of principles that allow us to make clear designs, and part of those designs have been the use of physical space, classroom space. Loosely, we call this the smart classroom, and this is not a classroom where the lights turn off when you leave the room. More, it's a room that's sensitive to who's in the room, what they're working on, where they are in the room, and where the walls and the furniture and even the floor can be leveraged for pedagogical advantage. So how do we design features of this room that play directly into the learning designs, the script, and that support the orchestration of that script to support our KCI learning designs? So the main conceptual ideas that we work with in KCI, which again stands for Knowledge, Community, and Inquiry, have to do with, first of all, an epistemological emphasis of collective inquiry or of a knowledge community. We want the students to identify as such. This means, in essence, we have to work against the prevailing ideas that students and teachers bring into the classroom of individual learners trying to even do better than their peers and compete with their peers. But in essence, where learning is an individual achievement, and even collaborative work is somehow cast in terms of an individual learner. So we work very, very hard on helping students and teachers understand this new epistemic position of learning as a community. Another important piece of the KCI model has to do with a collective knowledge base. So we set up KCI in terms of having a kind of a database of content that students would contribute to. Often that amounts to setting up the pages or the headers on pages, and then they would fill those in, or they would add photos, they would add notes, they would add artifacts, all of them indexed by the important learning goals and expectations of the curriculum. So we have the building of this knowledge base as an important goal for a KCI curriculum, and then correspondingly, the goal of making sure that knowledge base becomes a primary resource in the design of inquiry activities. So we're designing activities both where students build this knowledge base, but then where they need to have that knowledge base, particularly the stuff that was added by their wider peer community, as an essential resource for the inquiry project. So the learning space and the conceptual aspects of the future learning space come into how we use the displays and the large displays on the walls, the small displays in students' hands, to give the material in a timely fashion, in an as you need it fashion to students, So if I'm at a particular place in the room, and that place represents, let's say, a geographical region, then maybe the individual device that I have in my hand would display context-sensitive material that came out of the knowledge base relevant to the inquiry project that I'm working on. So these are principles that guide our design of technology features for the future learning space. There have been three main approaches that we've taken to designing the space conceptually. One of them is locational. So this literally means that we will kind of divide and conquer and put different important portions or subsections of the curriculum in different locations in the room so that students can semantically lighten the load in terms of when they're over there, they're doing this, and stuff that they get is related to that. Another one has to do with identity. So where I am in the room, if I'm with somebody else, that represents an intersection semantically of two individuals within this community, and also potentially the jobs that we have, if we have roles or specializations, if we have particular needs in relation to the inquiry project that we're engaged in. The third concept is situated or embedded phenomena. And this is a project I've undertaken with Tom Moore. I'll talk a little bit in more depth for later questions, but where we'll actually take a phenomenon, like in one case we took a digital simulation of insects and we sprinkle that all over the room. We embed that in the walls and students have to inquire about it. In another case, I worked with Michelle Louis, a PhD student, and we turned the entire room into a projected rainforest where the walls became objects of inquiry, and the students would walk up to one wall, it would be a Borneo rainforest, and the wall opposite them would be a Sumatran rainforest. And we actually leveraged the physicality of the room for important semantic differences. So I'll just give you some examples of how we've been able to address these conceptual goals for a few different projects. And I'll start in the first one. Is a high school biology project. This was done with Michelle Louis, who's a PhD student, actually now finished her doctorate here, called Evo Room. And with Michelle, we collaborated with a high school teacher to design an entire semester curriculum for, I think it's 11th grade biology. This was in topics of, the main topics were in biodiversity and evolution. And we targeted the concept of evolution because it's particularly challenging for anyone to instruct it well so that students learn it deeply. And we thought, hey, if we could actually win big with this collective inquiry project and with the future learning space approach and really help students learn deeply, then that really is something from a learning sciences research standpoint. So we designed a KCI curriculum where students worked very hard throughout the semester to think about the rainforest populations as they've evolved over 200 million years of time. We had them help us identify the species of today, but also where they descended from 2 million years ago, 5 million years ago, 25 million years ago, 50 million, 75, 100, and 200. So at 8 different time points, we then took those species and rendered them into a simulation and embedded that simulation in the entire classroom walls. So we used projectors, and we literally turned the room into a rainforest. We then built tablet computers to scaffold students as they investigated the rainforest and the transitions between time periods. So the teacher literally played the rainforest forward through time, and the students were scaffolded to approach different parts of the room looking for relationships, particularly evolutionary relationships from one point in time to the other. At the front of the room grew in real time a sort of collective visualization of the knowledge that those students were creating. This served as an important way for the teacher to reference the kind of growth or potential gaps or disagreements that she saw in the knowledge being collected. So without going into greater detail about the KCI design, this was one way that we used the future learning space within that longer curriculum to really anchor and engage the students in a physical form of inquiry. Nobody was sitting, and students were moving all over the room, and it really did solidify my belief that these future learning spaces can play an important role. The next example is from physics, where we actually used a very similar learning space, but configured radically differently. We had 4 stations, and at each station we put a Hollywood video. This was a video from some Hollywood movie where the physics were potentially questionable or at least of interest. So in one movie, for example, a car jumped a ramp and another car jumped over the ramp, leaving after the first one, but landed before that one. So several examples like that where students would have to literally say, I don't know if that's possible physically, or if it is, how can I set that up as a physics problem? And then we developed tablet applications to guide students. We used intelligent agents to help group them and to group them based on things that they had done beforehand. So in very real time, we were able to execute student grouping, send students off from one station to the next, such that by the end of the whole session, each student had worked at all 4 video stations. And by progressing and building on the group that had been there before, by the end they had all set up and solved all 4 of the video stations. This was done with Mike Tissenbaum, who is finished his PhD in that project, and you can read much more about that on the website. The third one is called Ecology, and it's a project that I've done with Tom Moore, where Tom invented a paradigm called embedded phenomenon, where he literally does embed a phenomenon in the classroom, whether that's in the floor, where it might be tectonic plates and students have to experience the rumbling of earthquakes and find where the fault lines are over a long period of many, many weeks. Or in our case, this was called Ecology, where we actually built a digital simulation of an insect colony, and we put that in the 4 walls of the room. We told the students there were bugs everywhere, but you could only see them when you were looking through the wall scope, which is a monitor on the wall. And then we encouraged them to do inquiry, and my team again invented the tablet and knowledge building component of this, where they actually had to collect observations, aggregate those at the front of the room, again for purposes of teacher-led discourse, and come as a community to an understanding of what the ecology was in these 4 walls. How were they different? Was the temperature higher in this one? How did that make an impact on the species that we saw? What were the life cycles? What were the food web relationships? So this helped grade 5, 6 students work as a scientific community to investigate a very captivating phenomenon that was literally embedded within their physical classroom environment. So in considering the challenges to this kind of work, I have to also consider the challenges to Kci Research. And Kci Research is intrinsically challenged by the need for substantive coverage of a particular topic. And that does present a very deep challenge to try to approach this as a collective learning community. You really need to collaborate with a teacher and think deeply about essentially how to revise an entire course or an entire unit and take up this kind of pedagogical approach. Intrinsic to that are the epistemological challenges that I mentioned. But related to the future learning spaces, obviously that it becomes a matter of designing technologies that are closely wed to the kinds of individual, small group, or whole class interactions that you are trying to achieve. A big one for us has to do with what's going on at the front of the room, and we do have a front of the room. There would be typically some growing knowledge base that's dynamic and you can see notes popping up and you can see a table filling in. You might see clear disagreements that are emerging where the teacher can point out, or clear gaps where we need more attention. Designing those is a matter of art and science, and it's typically a matter of some iterative work. So that's a very big challenge. Another one has to do with depth versus breadth. It's very, very easy in these substantive inquiry designs to go quite deep into a fairly narrow topic. And this is wonderful for everyone, including the teachers, but there's a responsibility on the teacher's part to cover the entire curriculum. And so we need to always hold the tension between designing for a deep understanding experience, but also making sure we cover the breadth of topics. So many practitioners in all levels are interested in how to develop new learning spaces. And this often takes the language of active learning environments or active learning classrooms. Or if I flip my classroom and I have the students essentially digesting the lecture material at home, then when they come in to school, what kind of physical learning space would they engage in? And there are plenty of interesting examples for you to look at, both in K-12 and in higher education, where this is happening. And there's a number of published case studies that you can look for. Some advice that I would give, that based on my experience as a researcher in those kind of environments, are first for flexibility. I believe in the power of projectors, and I think large displays are certainly critical for my work, and I think they can play an important role in a lot of different designs. For example, if you were to do a Pinterest activity or something like that, you would want to project the Pinterest board up front of the room. But basically, the kind of best examples of these learning environments that I know of are typically not fixed. So you don't have projectors mounted to ceilings. You have them sitting on a table. You have tables and chairs that can easily be moved. You have more, let's call them dumb boards than smart boards, boards that I can write on with whiteboard and markers and erase. Maybe I can take a digital photo of it if I really want to keep what's on there. Another important concern has to do with design. So it's one thing to have the physical environment and think deeply about the kind of learning that your environment could support, but your instructors are probably not experienced with designing and enacting this kind of learning. In my experience, it's very important from the outset to rethink how we're going to approach our learning designs. If you're going to use a learning community approach like I do, if you're going to have small table groups of kids working on problem solving, to design those activities is really a hard thing to do. It takes experience. I would encourage any institution that's thinking about doing this kind of learning to provide professional development for their teachers or instructors, to think deeply about the kind of theory that they're ultimately trying to inform their work, to consider partnerships with researchers or with to help teachers work as teams, and essentially to take the long view in how to transform learning within your institution.